So now that we have talked about matrix exponentials, how can we match it with solving with ODEs? And we also have thrown in the mix this matrix transformation that we haven't used yet. They all come together here. So we have our usual ODE system. X prime equals AX. We define a new variable. We define y that is such that x equals to ty. Then t times y prime equals ax. That is ty prime equals aty. Then we have y prime equals t at the minus 1 times a times t times y. That simplifies to y prime equals dy with all the conventions that we have just introduced. If this holds, then the solution for y is really easy because it's y equals exponential of dt times c, and d is a diagonal, so exponential of dt is a diagonal of exponentials. And it's multiplied by c that comes from the initial conditions. That means that we can replace back x in here. We multiplied both sides by t, and that makes us having ty equals t exponential of dt times c. So x, now that we have come back all the way, is equal to ty, so is equal to t exponential of dt times c. We have gone full circle. We have explained why matrix exponentials can be computed, and we have also seen how to compute them easily, because now we have gone to the point in which we can write the matrix exponential in the form of psi as the multiplication between a matrix T and the exponential of a diagonal matrix that is very easy to compute. Let's make an example. We go back to the matrix that we have been treating as well already. X prime equals 3, 4, 5, 2 times x. Then we have x equals exponential of at. Or we can write it as x equal t times exponential of dt times c. Notice how, well, first I forgot the initial conditions on exponential of at, but second, exponential of at, it's something we have only a power series formulation for, so it's not ideal. While it is the solution of any possible ODE system you can get, linear, it's not a computation of it. While on the other hand, t times exponential of dt times c, well, we can compute t and d. We have computed them. So by noticing that this matrix is the same matrix we worked with before, we can set in t and have it solve things. So with the exponential of a matrix that we had before, we get to the fact that we can rewrite xt as the first column of t times exponential of minus 2t, that is the exponential coming down from the first element of the diagonal d times t, times c1, plus the second column of t, that is the second eigenvector, exponential of the second eigenvalue times t times c2. This is a justification of what we did last week. Why could we do what we did last week? Because the exponential, the matrix exponential works as we have constructed this week.